confinement of Atlantic salmon. You would do really well to do redundant confinement if that's appropriate to further reduce risk. All right, so all this constituted one path to the risk assessment and management process. At this point, you're going to go and re-examine whether any stakeholder questions remain relevant or whether you've addressed them fairly well. Note that some questions can be answered by reviewing the literature, by consulting expert opinion, or by laboratory experiments as opposed to full-scale field experiments. Regulators should also be aware that only relevant questions should trigger new experiments. It's not every question you can conceive, it's the ones that are important that you want to focus on. Mandating studies disproportionate to risk increases costs and discourages the development and use of innovations. Further, risk assessment results generated in one country often will inform risk assessment in another. The transferability of findings promotes regulatory action and harmonization among countries. Now, I've been focusing, Andrew focused up here on the consultation process, the problem formulation. I've focused on risk assessment and risk management. It's important that there's feedbacks within this larger regulatory and societal process of risk analysis, that there's feedbacks so that you make the process adaptive. For instance, risk management should feed into what is your assessment of risk. Similarly, if there's regulatory approval and risk communication, and you go ahead and commercialize your genetically modified animal, there should be monitoring of outcomes, whether they're ecological, social, or economic, and that might feed back into your risk assessment. In any case, these are the feedbacks that make the system adaptive. In adaptive management, we become better at risk assessment as we go, and society accepts the results of risk analysis more readily. All right, so all of this probably seemed a little arcane, and I want to make some case studies here that will make this seem a little bit more real and a little bit more relevant to your work. So we're going to consider ecological risk on a case-by-case basis, considering our host species, our genomic change, and our receiving ecosystem. I'm going to consider slick cattle, myostatin knockout tilapia, and PRRSV-resistant pigs in Brazil. All right, so slick cattle. In terms of biodiversity protection goals, there's no obvious goal that's pertinent here. In terms of the biology of the organism, it's a non-native organism. There's no sexually compatible species in the receiving ecosystem. The dispersal of cattle is easily controlled. It's not invasive. It's not particularly relevant for the wildlife food chain. If it escapes, it's going to escape into agricultural ecosystems. The gene construct is a gene silencing. Is there a history of safe use? So there is, and so these responses suggest no greater risk than that associated with conventional cattle production. And so there's no obstacle to allowing this approval to go forward. All right, myostatin knockout tilapia. Biodiversity protection goals. Yeah, there's competing native species. What about the biology of the organism? Well, it's not native. There's no sexually compatible species in the receiving ecosystem, but its dispersal is hard to control, and it's an invasive species. And because it's an omnivore right in the middle of the food web, it is relevant for the aquatic food chain. If it escapes, it could easily gain access into ponds, rivers, and lakes that are appropriate for the survival and persistence of Nile tilapia. Right, the gene construct itself is the silencing of a myostatin gene. Is there a history of safe use? Well, there's not. In fact, tilapia is proven invasive in Brazil and in tropical and subtropical aquatic ecosystems worldwide. So risk management should be part of how we might consider approval of this species. We should not approve its use in open ponds because escape is fairly likely. But its use in well-confined recirculating aquaculture systems might prove acceptable. All right, let's consider a third case study, the PRRSV-resistant pig. In terms of protection goals, there's no obvious biodiversity issue here. It's non-native. There's no sexually compatible species. The dispersal likelihood is a function of confinement. Pigs are invasive. They do readily make feral populations, and they do pose a risk of harm to native ecosystems. 36 states in the United States have feral hog populations. In southwestern Virginia, where I'm from, I can show you forests where they've absolutely rooted up everything and had a lot of impacts. I can't imagine it would be any different in Brazil. The receiving environment immediately is the agricultural ecosystem, but there are adjacent wild ecosystems as well. Again, the gene construct itself is not what poses harm, it's the animal. So the history of safe use, well, to some extent. This suggests the need for effective confinement, not in a small farm pigsty side, but in a confined animal feeding operation. That's probably okay. All right, so what then are the take-home messages that I'd like to leave you with? First of all, environmental risk assessment is relevant for regulatory oversight of many genome-edited animals. Getting back to problem formulation, frame the relevant questions thoughtfully in the context of the product and its production in your regulatory context and in your receiving ecosystems. Qualitative risk assessment will prove sufficient in many cases to identify, estimate, and manage any risks. Now, I can only begin to introduce you to ecological risk assessment in a 15-minute talk. And there are many resources I could share with you, but there's one that's available on the web that is at a great level for people that are just introducing themselves to it. And so here's the URL for it. I'd be happy to share my talk with anyone that might want it. And thank you, Marianne.